Let's take a look at this problem. It says complete the table to determine P for the given values of the final balance of 200,000. And R is 4% compounded quarterly. Well, quarterly means we're going to use this formula. A is equal to P times 1 plus R over N to the N T power. If it doesn't say continuous, use this one. And specifically, we want to find what P is equal to. So I'm going to divide both sides by 1 plus R over N to the N T power. 1 plus R over N to the NT power. And that's going to be P. Let's see what they give us. Final balance of 200,000, so they're telling us A. Divided by 1 plus R, which is 4%. Divided by N, compounded quarterly. That means N is 4. Raised to the NT power. Well, T is when the variable is changing. And N is 4, so we're going to have 4, and I'll put a variable here of X equals P. Now, if you have more than a single number or a single variable in your exponent, you should put parentheses around it when you plug in your calculator. So I'll put parentheses around the 4X. Excuse me. So let's plug this in our calculator. Okay, so I'm going to press my Y equals, clear, 200,000, beginning parentheses, 1 plus 0.04 divided by 4, closing parentheses, caret, and then beginning parentheses, 4x. So I just typed in what we just saw here. Now I want to do make sure my table setup is correct, so I do second window, and your independent should say ask. If it doesn't say ask, you down arrow to that line, right arrow, and you press enter on ask. Now we go to our table, so we do second graph, and we're ready to start finding what they're asking. T is equal to 1, T is equal to 10, T is equal to 25, T is equal to 50, T is equal to 100, and T is equal to 500. So 1, 10, 25. So 1 enter, 10 enter, 25 enter, then 50 enter, 100 enter, 500 enter. Now I'm going to right arrow over and up arrow. Okay, go up here. So on this one, we got 208,120.80. So you end up with 200,000 at the end of 1 year. You'd have to, or wait a minute. Oh no, that's your I think I've forgotten something here. Okay, I forgot to divide. Let me go back to y equals. Okay, that makes more sense. I'm sitting here. Shouldn't have put 208,000 in to get 200,000 back. Okay, second, delete, and then I'll put my divide in there. Okay, now I'll go to my table. Second graph. That looks better. Yeah, well, it'd be kind of bad, wouldn't it? You had to put 208,000 in to get 200,000 at the end of that time. That means they're stealing money from you. It's like a regular checking account. Let's see, 192,196.07. So if you leave your money in for a year, this is how much you'd have to deposit in order to get 200,000 at the end. For 10, we down arrow to that. It's 134,000. 331 or 330.63. I'm looking at this number down here at the bottom, not the rounded one up here. Then I'll do a down arrow. 73,942 and 24 cents. And down arrow for 50. 27,337.28. Down arrow. And 337.36 and 63. And down arrow again. And this is scientific notation. It'd be 0.000455, which basically means a penny, since you can't deposit less than that. If you put a penny in and leave it for 500 years, then you'll end up with $200,000. It's pretty wild to think about. Now let me double check my entry here, since I screwed it up the first time. 200,000 divided by 1 plus 0.04 divided by 4 caret to the 4x power. Okay, that looks right. So those are our answers.